Today we are going to learn how to tell whether two triangles are similar. You should be on page 20 in your notes packet. Remember that when we're talking about similar figures, that does not mean that the figures are congruent. What that really means is that the figures have been enlarged or they have been reduced at the same rate. So there are three main ways of determining whether a triangle is similar. We can use what we call angle-angle similarity. And in angle-angle similarity, we know that if two corresponding angles are congruent, then the triangles are similar. Well, when we say corresponding angles are those angles that are in the same position, but in the other triangle, in the either reduced or enlarged triangle. So let's look at number one. You see that you have triangle ABC, and it looks like it has been reduced to create triangle DEF. If these are similar, then that means that two corresponding angles will be congruent. So when I look at angle A, I see that angle A is 75 degrees. Well, when I look at this triangle for DEF, I see that A and D would be in the same position. So those do have congruent corresponding angles since 75 is equal to 75. The problem is that B corresponds to E, but E does not have an angle measure. And I also cannot compare C to F, even though they are corresponding angles, because even though F has an angle measure, C does not. So I would need to use what I know about triangles. I know that the interior angles of triangles add up to 180 degrees. So I need to figure out what either C or E equals. If I'm just going to look at my first triangle, I can figure out the measure of angle C by doing 180 minus 74 minus 75. When I do that, I get a measure of 31 degrees here. Well, if I look at C and compare it to its corresponding angle of F, I see that those angles are congruent. Since there are at least two angles that are congruent, I know that these two triangles are similar by the AA, or angle-angle similarity. Now for number two, I am going to look at these triangles and see if they are similar. Well, when I look at this triangle, WVX or XWV, however you want to say that, I see that it looks like it's kind of been flipped over and flipped this way. So it looks like it's been flipped two different ways to get where it ended up over here. And it also was reduced to create triangle XYZ. Well, so we have to figure out where our corresponding angles are. So with this, it's kind of complicated. A good way to do this is to redraw at least one of them so that it's the same as the other. So if I redraw W, V, and X, I know that this angle over here is going to be X. But you see that I would have to flip this up and then flip the whole thing over. So what happens is V ends up over here. And V, even though we don't know what it equals, we know that it is congruent to Y. And then that leaves us with W flipping down here. Well, now if I compare this to this one, I can see that V and Y are corresponding angles, and I know that they are congruent. I know that they are congruent because of this. This and this tell me that these angle measures are equal. So I know that V and Y are congruent angles. But when I look at W, I don't know what W equals. I also don't know what Z equals. So I know that W and Z are corresponding angles, but I don't know what either of them measure, so I cannot use those. So instead, I need to use X. Well, I can't use it from this drawing, so I need to go back to what I know over here. Both of these are X. But if you think about what we know about intersecting lines, we know that when two lines intersect, they create vertical angles. So what happens is, even though I don't know what these angle measures right here equal, I know that they are congruent to each other because they are vertical or opposite to each other. So because of that, I know that these two corresponding angles are also congruent. So I have corresponding angles that are congruent with V and Y, and I have corresponding angles that are congruent with X. So because I have two, I know that these two triangles are similar based on the angle-angle theorem of similarity. One of the easier ones is side-side-side similarity. Now, obviously, we're not looking at congruent triangles, so we're not looking at two sides that are necessarily congruent, but corresponding side lengths are going to be proportional. And if they are proportional, then that means that the triangles are similar. So if I look at number 3, I have triangle PQR and triangle STU. Well, I need to look at corresponding side lengths. So I know I can see that 3 corresponds to 6. So in order to figure this out, what I'm going to do with my corresponding side lengths is make them into ratios. So I have 3, which corresponds to 6. Now what I'm going to do is see if all of these are equal. I have 5, which now corresponds to 10. So I'm going to put 5 over 10. And then I have 4, which corresponds to 8. So I have 4 corresponding to 8. Now, when I look at those, it doesn't really tell me much. What I need to do is simplify all of these. Well, I know that 3 over 6 will simplify to 1 over 2. 5 over 10 will also simplify to 1 over 2. And 4 over 8 will also simplify to 1 over 2. Well, when I look at these in simplest form, I see that all of these ratios are congruent or proportional, which means that all of these side lengths were enlarged at the same rate. So that means that, yes, these triangles are similar, and we're going to use the side-side-side similarity to prove that. Now let's look at number 4. We have CDE compared to FGH. Well, it looks like these haven't been turned or flipped or anything, so it looks like CD corresponds to FG. So we just need to look at our ratios. Well, so we have 30, which corresponds to 24. So I'm going to say 30 over 24. Then we have 35, which corresponds to 28. And finally, we have 32, which corresponds to 25. Well, now what we need to do is simplify all of these to their simplest form. Well, when I look at 30 and 24, I know that the largest number that goes into both of those is 6. 30 divided by 6 would give me 5, and 24 divided by 6 would give me 4. So that one simplifies to 5/4. For 35 over 28, I know that both of those can be reduced by 7. So 35 divided by 7 gives me 5, and 28 divided by 7 gives me 4. Now for 32 and 25, I don't know that they have anything in common other than 1, because I know that the only thing that goes into 25 is 5, but 5 will not go into 32. So that means that that ratio cannot be simplified. Well, when I look at this, 5/4 and 5/4 are equal. but then 32/25 is not. So because of that, I know that no, these are not similar. The last way that we can tell similarity in triangles is using the side angle side theorem. What this means is that we would use two corresponding side lengths, and those would have to be proportional. And then we would look at the included angle. So if the corresponding side lengths are proportional and the angle between them is congruent, then the triangles are similar. So for number 5, you can see that we have triangle JKL and triangle MNP. Well, you see that we have two side lengths on these. So we have 8, which corresponds to 6. So we're going to say 8 to 6. And we also have 20, which corresponds to 15. So we're going to say 20 to 15. Well, we definitely need to simplify both of those. If I look at 8 and 6, I know that both of those can be divided by 2. So 8 divided by 2 is 4, and 6 divided by 2 is 3. With 20 and 15, I know that both of those can be divided by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. So the two side lengths that we have are proportional. Now, in order for this to be similar, then that means that the congruent or the corresponding angle, and it says the included corresponding angle. What that means is I had a side length here and here that I was comparing. Well, I would need to look at the included angle, which is this angle right here, angle K, because that is between these two side lengths. So over here, I would need to look at angle N because that's in between these two side lengths. Well, what I see is that they both have this mark, which tells us that they are congruent to each other. So since the side lengths are proportional and the included angle measure is congruent, then I would say that yes, these are similar because of side angle side similarity. Now let's look at number 6. Number 6 looks complicated. It's not as hard as it looks, though. You see that we have two triangles, and it's hard to see those, but you have triangle ABC, which is this large triangle. And then you also have triangle ADE, which is this smaller triangle included in here. Well, let's start with just side lengths. I am given two side lengths for ABC. I'm given this side length over here, which is 25. So from A all the way to B, that measures 25. Well, that corresponds with A to D, and that measurement is 15. So I'm going to use 25 and compare it to 15. Now for this one, the measure of A to C is 21. So I'm going to compare 21 to its corresponding side length, which is 12. Well, we need to simplify these. So if I look at 25 over 15, I know that that can be simplified by 5. So 25 divided by 5 is 5, and 15 divided by 5 is 3. For 21 over 12, I know that both of those can be divided by 3. Well, 21 divided by 3 is 7, and 12 divided by 3 is 4. Well, if I look right there, my side lengths are not proportional. So because of that, I know that these are not going to be similar. So I would say, no, they are not similar. Now, the included angle measure here, because you might see some that are like this, the included angle measure between AB and AC was A. And the included angle measure for AD and AE was also A. So since this angle is the exact same on both of them, If these had been proportional, then that would have been a similar triangle. But because these two were not proportional, it doesn't matter about the included angle measure because they didn't meet both criteria. So these are not similar.